let's talk about capacitors in series. Capacitors in series. So we have two circuits, two equivalent circuits. For our first one, we have our battery like so, and it's connected to three capacitors in series. And each one of them has a capacitance, a different capacitance, C1, C2, and C3. And we know that the current is going to flow this way. Now we have an equivalent circuit where we have the same battery as before, but this time we only have one capacitor. And this capacitor has a capacitance of C. Otherwise, everything else is the same. And we want to know what is the relationship between C and C1, C2, and C3 in order for these two circuits to be equivalent. Well, we know one thing, namely that the Q, namely the charge that is stored by any capacitor, is equal to C, its capacitance, times V, the voltage. Now let's consider this circuit on the left. We know that the charge on the Q, the charge on each of these, must be the same in order for there to be, once they are all charged, so once all three capacitors are charged, we know that they must have the same charge because there is no longer any movement. There is no movement of charge. If there was a difference, if for example Q1 was greater than Q2, then charge would flow from Q1 to Q2 because there would be an imbalance of charges and thus a force that would cause them to move. And so they would keep moving until equilibrium is reached, at which point all the Q's would be the same. So given that all Q's are the same, another thing that we know is that the total V of the battery must equal the V across our circuit. So we have namely that V1 plus V2 plus V3, which is the voltage across each of the capacitors, this must equal the total V. And since we know that Q equals CV, V is just Q over C. So we have Q1 over C1 plus Q2 over C2 plus Q3 over C3 equals V. Since we know all the Q's are the same, we can take it out to find that Q times 1 over C1 plus 1 over C2 plus 1 over C3 is equal to V. Now, what if we see this side? Well, we have the same idea where we have Q equals CV. And our V is the same as our circuit on the left. Same as our circuit on the left side. And we also look at the Q. We also have that the Q in this case is going to equal to the same Q over here. So we have that V is equal to Q over C. And if we set these two to become equivalent, we find that Q 1 over C1 plus 1 over C2 plus 1 over C3 is equal to Q over C. And by canceling out the Q's on all sides, we find that for three capacitors in series, we have that 1 over C is equal to the sum of their reciprocals. And we can conclude by looking at the pattern that if we had more capacitors in series, we would simply be adding their reciprocals. And thus we find an expression for capacitors in series.